Hi everyone. Today I'm going to talk about how to use ANSYS to analyze soil mechanics. There were a bunch of tutorials online about using ANSYS to do mechanical engineering, things like or some other engineering, but there were few of them were about soil mechanics. So that's the purpose of the video clip. Okay, here I want to introduce the problem. This is a very simple problem. I simplify this and I make assumption of rigid building. Here's a rigid building wall and a rigid rock base. The building is set on rock base. And here's some sandy soil, which elastic soil has the elastic modulus and Poisson's ratio. Here's dimensions, 30 meter, 5 meter. And here is some kind of thick wall building near the high building. And we could consider it as a strip load. So the width is 1 meter, the height is 2 meter, and has density of 2.5 times 10 to the 3 kilogram per square meter. And the question is to find out where has the maximum pressure on the rigid building. And of course, using finite element, we could find the pressure distribution in the soil. Okay, doing this, we'll start up the ANSYS. I'm a student in University of Maryland, so I use the virtual lab. Log on, and we see ANSYS 13. Click it, and waiting for it to start up. Okay, starting application. Okay. Oh, by the way, the reason I use ANSYS to do soil mechanics problem is because ANSYS is pretty wide available around the country. Unlike Abacus, which is pretty more expensive software, ANSYS might be, I don't know, I guess maybe cheaper, so it's wider available here. Okay, here is ANSYS. And I just start up. It's pretty new job. So first of all, I want to save the job on my hard drive. Be very careful here. Here shows C disk, but it is not the C disk on your disk. It's a C disk on the server. So if you save it here, you won't find it anymore. So you just click here, and you will find something like client C and dollar, which is vdisk. I'm using Mac, so I use this. This will actually gain access to my local hard drive, so I could save things on my local hard drive. Read and write. We see here's the previous thing I did, but here I want to save it as demo 1. Remodel. Okay. Click OK, and here we are. So first of all, I want to introduce the general 3 steps in ANSYS, which is preprocessor. We're doing modeling here. We plot the geometry model. We assign the material. We define the element type, and we define the meshing. Okay, and solution. In this problem, solution is pretty straightforward. Just solve the problem. But before you could do the solution, you need to apply loads here. And in ANSYS, I think you could apply loads in both preprocessor or solution. I recommend solution because I read the material and I did it in solution. Okay, and solution, we just could find the define the load, and actually the constraints are part of the load. I don't know why, but you define the displacement constraints in the load, and you also define some force or like pressure in the load. So let's have a look. Here is define loads. Okay, and general post-processor, which is the last step, where we could find the numbers, where is the maximum pressure, and we could do the plotting, like a contour plotting or doing animation. Okay, so first of all, we go to preprocessor, and here's an element type. We don't use it here. Real constant, we may use it later, but first of all, we go to moduling. I don't know why they put moduling at the 5th, but I really think it should put it first, but I don't know. We use that first. So you use moduling, we just create. We create an area, and we want to do the by dimension. So I wanted starting with 0, and because it's about 5 meters apart, so I wanted, for example, to put 100 here, so it will be far enough to represent the infinite soil. Okay, for y, it's 30 meters deep, but I want to use it starting from 0 to minus 30. Oh, it's going down. Okay, just click OK. here is our soil. And okay, after we got this, we know that we need to define loads somewhere around here. So in ANSYS, we couldn't define loads, define pressure on element. So we need to define pressure on line. So we need to make a new line here. So we go to line. Now, not create. We use operate because we want to divide this line, the top line. We use Boolean, and we use divide. So divide here, divide line with options. So first of all, I'll let you choose this line. So just click this line, click OK, and here we are. Here's how many lines you want to create. We want to create 2 lines based on this line, the ratio. The ratio means, the newly created line over the original line. Here is that ratio of line lengths, but it's not like the 2 lines 1/1. It's just the new one over the original one. So the ratio should be from 0 to 1. So here, the length is 100 meters, and we want to create the first line about 5 meters. So we put 5 meters here, over 100 meters. But here, another thing I want to tell you is, if you put this here, it won't do that, because in ANSYS, the dimension for the line goes counterclockwise. So you'd better put 95 here. Okay, and the key point is name. It's 1, 2, 3, 4, so we assign it to 5, and the original to be modified. So click OK. Here is a little dot. Maybe you found it's hard to see. We go to plot, plot control, go to numbering. We number the key points and the line. You see the key points numbers and the line numbers. We click OK. Now we see it. Okay, and using plot, we just want to plot lines. Here we are. Here's our lines. That's line 3, line 5, and here it is. And we also want to divide a little 1 meter line in here, which we want to put the strip pressure on. We click here, we choose this line. Okay, press OK. 2 lines. So here there will be 94 over original one's 95. The number I want to call it 6. Okay, so here we are. We got a little 1 meter line here. So basically, here is what we got for the geometry plotting. And then we will assign material for our, soil. So we go to material properties. But first of all, I want to assign the element type because it's elastic modulus, elastic soil. So we want to add the element type. We want to add the solid and 8 node 183. We'll talk about this later. Okay, it's a quadratic and high order element, so it will give you more precise solving the result. Okay, apply, and we tell no more. This cancel. We have that, and we click options to define something. For example, for the soil mechanics problem, we always use plane strain, okay, and the pure displacement. They mixed it up. Okay, we'll talk about this later. And the quadrilateral, that's okay. Press OK, and we define the element type and real constant. In our problems, this problem, there's nothing to define. If you're using you're doing a plane stress problem, maybe you could define the thickness of the element. That's the real constant. Okay, material type. We go to a material model. Here we go to structure model, we go to linear, we go to elastic, we go to isotropic. And for the elastic modulus, as our previous state, it's 7e 10 to the 5 kilopascal, but to be consistent in unit, we should use Pascal. So that would be to the 8. Okay, Poisson's ratio, that's
it's 430.
3. Okay, we click OK. We define this linear material. Okay, after that, we want to mesh the model.